Next we will see the color properties. Now whenever if you have unpaired electrons, then they will be colored. Otherwise, if you don't have any unpaired electron, they are what? Colorless in nature. Now we have taken number of ions here. First of all, we will see why this exhibit the color. For example, if you have any unpaired electron is there, so actually this is the nucleus plus orbit. If you have any electron is here, which is unpaired electron. Now when it absorbs the energy, if this electron absorbs the energy, this will jump into higher energy level, and again it will come back into its ground state. This electron is entered into higher energy level, coming back into ground state. So when coming back into ground state, it will emits visible region, emits radiation of visible region. So whenever if emits radiation of visible region, they emits the colors. So only when you have unpaired electrons, this should be must be unpaired electron only. If you have unpaired electron is absent, this type of phenomena is not observed. Now we will take scandium plus 3 will have 3d0 configuration. So there is no unpaired electron, colorless. Titanium plus 4 3d0 colorless. Similarly, copper plus 1 3d10 means what? All are paired electrons, there is no unpaired electron, colorless. Zinc plus 2 3d10 all are paired electrons, colorless. So how many are colorless? Zinc plus 2, copper plus 1, scandium plus 3 and titanium plus 4. These are what? Colorless in nature. Scandium plus 3, next titanium plus 4, next titanium, copper plus 1 and zinc plus 2. These are actually what? Colorless. And remaining all are having C 3d1, 3d2, 3d3, 3d5, 3d8, 3d9. They are having unpaired electron. They exhibit this type of colors here, isn't it? Next important thing is that how to write the electronic configuration, that already we discussed 2 times in the first class and the previous class. Again I am explaining how to make this configuration by taking 1 or 2 examples. Let me take one example here. What will take? Vanadium plus 3. How to make vanadium plus 3? See, take first of all vanadium. Configuration will be 3d3 4s2. This is the general configuration of vanadium. Now vanadium plus 2. How to write vanadium plus 2? Isn't it? The plus 2 is not there. I am writing directly plus 3. Okay. Now, vanadium plus 3 means how many electrons we have to remove? 2 from here, 1 from here. So what we get here? 3d2 4s0. This is 3d2, unpaired electrons are there. Vanadium plus 4, how to write vanadium plus 4? 2 from here and here minus 2. Then we get here 3d1 4s0. In this way we have. We take one more example, cobalt iron plus 3. Iron will be 3d6 4s2. How to make iron plus 3 here? 3d, first you write iron plus 2. Remove electrons from 4s orbital. What we get? 3d6 4s0. Next iron plus 3. So 3 electrons we need to remove. 2 from 4s orbital, 1 from the 3d6. So what we get here? 3d5 and 4s0. So unpaired electrons are 5, 3d5. In this way we have to make. So this is about the color properties. So actually in examination they will ask colored or colorless. No need to remember particular colors actually. Remember whether they exhibit color or not. Colorless or color. How you get colorless? If you don't have any unpaired electron, colorless. If you have any unpaired electron, they are what? Colored molecules. One more thing here. If you take Fe plus 2, Fe plus 3, this is called what? Ferrous. This is called what? Ferric. Similarly, Cu plus 1, cuprous. Cu plus 2, cupric. Right? Now, Cu plus 2 is blue color, Cu plus 1 colorless. That means cuprous is what? Colorless. This one is colorless. And cupric is what? Colored thing. For example, I will take what? CuCl2. The oxidation state copper will be what here? +2. It will exhibit which color? Blue color. For example, if I take what? CuCl, oxidation state will be +1. Cuprous chloride. It will be colorless, isn't it? So in this way also you may get questions like this.